Welcome again to Wickerson Studios. My name is Michael Wickerson, and I am doing a test version beyond the working process of Rhino 7. So I've downloaded it and gotten a license for the next 3 months, and I will have to upgrade it for the $95 soon enough. But I'm into Chapter 4 of this Chinese text on GH Python scripts. The scripts are fairly simple. As you can see at the bottom here, I've basically brought in a node. It's dealing with recursion within this first section. So what I can do is just have a look at the script that I'm playing with. We'll just move this one up. And you'll see there's a Python node here. There's a little post node that I'm doing a little bit of extrusion on the curves coming out, and I'm keeping those numbered to the list lengths. A very simple excursion exercise. So you're dealing with these curves right here. I believe 6 of them currently. Yeah, 6 polylines. And then I'm extruding those and keeping that data. And then what I did here was I actually added to the script in the text by using a polygon that you can change the count, which is very nice. Get some very interesting shapes. Down to 3 probably will be good to edit that and bring that to a minimum of 3. There's no point having a 2-sided or 1-sided or 0-sided polygon. And then that kind of extrudes to that. And as I move this up, I just have I have a factor of adding a digit to it. So as you add a digit, you can get these really nice subtle curves as you rotate. I think that's kind of nice. You see the bottom one, the way it staggers out, and it's odd and even numbers. It's kind of a nice one on the right angle. So just a little bit of math before and a little bit of geometry afterwards. But otherwise, the script is pretty basic. Let's bring this one up. Shrink it down to the size of the GH, and the script I'm not going to make it too complex, and I'm not going to make a tutorial on Patreon because it's right there. It's a function of draw poly using a polyline degree, creating a point list, segmenting it from the Rhino script function explode curves at that polyline, and for the iteration you do it from the length of the segment, which is being defined by function of whatever that segment count is, and then the point is using the divide curve function, which I don't think I've used yet, which needs a segment and a list item, which is the iteration at I, and I'm going to divide that. And after the divide, I could have just divided by an integer 5, or I could have hard-coded it, but instead I brought it in by this, which is where I did a little bit of pre-math that I would drop below it, but a lot because it would pitter out if I set that to something like 3. I'll just show you that. So if I brought that in, you can see it's not going to function. So let's not go below that. So I just did a little funkiness there, and it allows for obviously being able to have a little bit of play with what's happening. Then the points are appended by those point at the 4 count, which is fine. I guess I could change those numbers, and I could change where I'm grabbing the list items, but I'm going to leave it at 4 and leave it at 0. Here are the points append point 0, and then the new polyline is adding the polyline function, which needs those points to do so, which have been appended. So you can just read backwards in your script. The polyline list is appended again with the new polyline, and then if the degree is greater than 0, because I don't want to go less than that, you simply draw the polyline and then walk the recursion down until it gets to 0. Otherwise, I guess it goes on forever in some strange way, and return the polyline list. Then you have to make the polyline list, empty list. You want to append that from your start polyline, which is basically what's being generated, and the start polyline is the number that you're bringing in. So let's have a look here. We've got one polyline curve, and so using that curve, you can count backwards by 1, and then you'll want to do your polyline list out and make sure you set that. The only thing you have to remember to do is set this one the integer. So you have to jump in here and use your type hint integer, and you'll have to do the same with the list. And for the start line, don't mess up and change that to anything. You'll actually go in there and keep that as a GHDoc object with geometry. And I think that has something to do with the GUID. So I just want to leave that blank. And I tested that script up here where I could just bring in something and start polyline and make sure that was producing something. So I'll go here and it just makes me a list. It makes me an empty list, I think. So as I go in here, you'll see it sets at 0, 0, 0, and then 0 as null. So that's functioning, and that's why I got that up and running off of the text. So otherwise, not too hard. The script is fairly simple. The Python script is simple enough to get in there and try a couple of new functions. Maybe I'll do a simple tutorial on, or a list of all the functions that are being used in Rhino script. And although I wanted to go into Rhino Common with this, it's complex enough to begin with these functions in Rhino script. And then I can get playful with it geometrically. And the things I can do with this simple Python node as I start to make it into more complex geometries. I like the conciseness of this. I like the little techniques that I've used before to extrude. Of course, if I wanted to extrude it less, I still can have that function. And I can set it back down to 0, but I probably, I mean, if I wanted to bring that count up to 10, I guess I could edit that slider, bring that up to 10 count, obviously not as high as the other one. And then I can start that differently, so I can have it just a little top of that if I wanted to change the shape of that geometry. I'm not bringing this in the Rhino script. I'm not capping these. I'm not doing any booleans, but I'm basically generating some interesting geometries. And let me just slide this over, do a little bake. We'll do a bake and not bring them all in the same file, so then we've got our little tiny shapes all separate, all 10 of them, that we could do, and we could render differently if we wanted to. So, fun. Fun little exercise, producing some pretty cool things from very simple recursion exercises. I'm going to go on to fractals after this, but it's chapter 4 of the GH Python script node book, and hopefully you guys find this interesting. Rhino 7, and I'll see where it takes me. Thank you for watching.